Hello, welcome to What is Engineering from a Geological Engineering Perspective. My name is Donna Beneteau and I'm a professor in Geological Engineering. What is engineering? Engineering is applying science. So in geological engineering, I think we're the stewards of the earth, of this planet. So that means that we're looking to take care of what's under our feet. So that could be sedimentary rock, igneous, metamorphic, water, and maybe eroded soil. In this video, I'm going to introduce you to 4 activities to help you get to better know the natural resources in Saskatchewan. We have 8 different disciplines of engineering at the University of Saskatchewan, and within the department I'm in, CGEE, we have 3: civil, geological, and environmental. So again, I'm a geological engineer and I love rock. And the rock at the University of Saskatchewan is really cool because when they started building the campus, they found this limestone in a quarry north of the campus. So if this rock is limestone, what does it tell you about Saskatchewan, how it was formed? So why do we need mining? Why do we have to keep filling a planet with holes? It causes CO2 emissions, we have global warming. There's a saying, if it can't be grown, it must be mined. So in order to keep the quality of life that we want as humans, we need to be extracting resources. We're feeding families around the world by making their crops more fertile. So my question for you is potash a sedimentary, igneous, or metamorphic rock? So why do we care when rocks are sedimentary, igneous, or metamorphic? The obvious reason is if we're going to mine the rock, we need to know how nature concentrates the valuable minerals based on how they were deposited. That is how the geologists build the puzzle of where to explore for the different minerals. These are all rocks that are mined in Saskatchewan. I expect that you figured out that the potash and dolomite were sedimentary. Saskatchewan was actually covered by an ancient ocean, and these would have been deposited when the ocean dried up. So here are some of the other cool rocks we mine in Saskatchewan. So we saw the potash and the dolomite. This is sandstone. And what's interesting, even though these 2 rocks look the same, if I sprayed water onto this dolomite or limestone, it would just drip off, but the sandstone would just absorb it and absorb it like a sponge. So that's why the petroleum is stored in sandstone deposits. Then we have potash. In the ancient ocean, there would have been mud, and when it settled out, it formed mudstone. And all the plants and living organic matter that was in the ocean would have decomposed into coal, which is found in the south part of the province. A new exciting discovery in Saskatchewan are the diamond mines located 60 kilometers east of Prince Albert. And this is a core from the diamond mine site. That's called KIMBERLITE, and that's igneous. And then we actually have an operating gold mine. SSR Mining right now has the Santoy mine. And if you zoom in on this rock, you can actually see visible gold on the rock. The yellow off to the side is pyrite, which is called fool's gold. And if we didn't have the actual visible gold, we might think that's gold. And this is a rock from one of the copper mines in Canada. So now I'm challenging you to activity 1, where you take my map of Saskatchewan and try and figure out where the sedimentary, igneous, and metamorphic rocks are mined here. So as geological engineers, we need to measure the properties of the rock and quantify what the characteristics are. So things that we're concerned about are how strong, how wet, how bumpy, and maybe joint angles. So thinking of our potash again, if I was to hit this with this rock, it all easily falls to pieces. So that's not a very strong rock. But I could knock on the big rock and it's never going to break. So how we measure strength in the lab is we take cores. The drills do core when the geologists are exploring to find the valuable minerals. And we cut off the ends and make them smooth. And then we compress them until they break, and that tells us how strong the rock is. In terms of how bumpy, we use this, which is just a carpenter's profile comb. And we can just tap the rock and get different profiles of the joints. And if a rock is really bumpy, imagine another piece of rock on top. It's going to be harder to slide off than if this was perfectly smooth like the top of this rock is. The other property that's super important about rocks is joints. And I love this folder here because obviously before there is a big wedge of rock that was in here that's fallen out. And if we can kind of estimate what the angles of the joints would have been. And why this is so important is because if we're trying to tunnel through the rock, let's say through a mountain or in a mine, we need to know if these wedges could fall down and injure our workers or our equipment. So then we design support based on the size and shape of the wedges that are in the mine. So here's activity 3. Go to your garden, go explore your neighborhood, find a boulder and describe it. So my colleagues and I, our interest is in extracting the rock, but then the mineral processing engineers go on to extract the rock into its pure form. And if you look up close, you can see all the different elements in the periodic table. To point out a couple of really cool elements on the periodic table, we have gold. I got the little nugget when I was in Dawson City a couple of years ago. They still find gold in the streams there. I really like mercury because it's liquid at room temperature if you look at an old-fashioned thermometer. Here's a diamond in its natural state as it would have been taken out of the ground. It's from the Ekati mine in the Northwest Territories. Everything we use is either mined or grown, so if it didn't come from a field, here it is on the table, purified. And it's up to the other disciplines of engineering to figure out what to do with it. So a rock mechanics lab, which is where I work in geological engineering, we have different saws and different drill bits so that we can prepare rocks to the shape and size that we need. But I just went into my garden and I used one of our rock saws to just slice different small rocks. As engineers, what we really need to measure as a property of rock is density, which is just mass over volume. So imagine all these rocks around us. These all have a density of about 2.7 grams per centimeter cubed. Remember my rock from the Santoy gold mine that has if they extracted the gold, it has a density of like 19 grams per centimeter cubed. So if they purified the gold and filled a truck that is made to carry 2.7 gram per centimeter rock, the tires would probably burst and the axles would probably snap. So I'm going to leave you with a project that I'm working on. I'm building a historical database of the mines in Canada since Canada was formed. If you're curious about the mines in Saskatchewan, you can go to the Saskatchewan Mineral Deposit Index online and retrieve this map, and you can learn where the mines are in the history of Saskatchewan. So I did activity 4 for all of the geological databases I could find in Canada. At the beginning of the video, I told you it was easy to dress for today. So one way that our lives are touched, then that we might not even realize it, is that Levi Strauss invented the blue jeans for the California gold rush because they were durable and they were tired of their workwear wearing out. Thanks for popping by to see our video. If you think geological engineering rocks, check out some of our other videos.